What if we're not alone? What if life as we know it is just a tiny part of a much larger cosmic symphony? Dear traveler, welcome. Today we're diving into a dizzying quest in search of the signature of extraterrestrial life. From the subterranean oceans of Europa to the clouds of Venus, where strange chemical compounds float, from the dry valleys of Mars to distant exoplanets with enigmatic atmospheres. We'll cross the universe in pursuit of those clues that might finally reveal that we're not alone. But before we set off on a new adventure, remember to like this video and subscribe to the channel so you don't miss a thing. Thanks and have a great trip. In the solar system, our planet is an exception. Life in all its forms, from the simplest to the most complex, can be found everywhere, even in the most extreme environments. High altitudes, deserts, abyssal depths. It took billions of years for life to emerge, adapt, and evolve, until it spread across the entire surface of the Earth. Initially underwater, it colonized dry land to give rise to plants, animals, and human beings. But is the Earth really an exception? Today, researchers are convinced that life exists somewhere else in the universe. This life may be very different from that which exists on Earth, so different that we have yet to detect it, but it must exist. Statistically, it seems impossible that somewhere in the universe there isn't another form of life that has persisted and evolved over a period of millions or billions of years. To date, over 7,300 exoplanets have been discovered. In our own Milky Way galaxy alone, there are an estimated 300 million potentially habitable exoplanets. Knowing that there could be over 2,000 billion galaxies, you can easily imagine the number of possible worlds. Scientific research shows that microbial life is widespread throughout the universe. A 2020 study even estimated that there should be at least 36 advanced civilizations, i.e., capable of sending communication signals across the Milky Way. The problem is finding them. Looking for life in the universe is like looking for a needle in a haystack. The observable universe is no less than 93 billion light-years across. How can life be detected in such an immense space? From the American SETI program to interstellar archaeology, which aims to identify traces of extraterrestrial life in the universe, the search for life elsewhere than on Earth is now a discipline in its own right with astronomy. To detect a trace of extraterrestrial life, scientists look for unusual signals, such as light patterns or radio waves. For example, an object that flashes abnormally can be interpreted as a sign of extraterrestrial life. Scientists will also look for possible traces of past intelligent civilizations, such as messages or artificial structures created by these civilizations. The search for biosignatures is an important part of the quest for life in the universe. What are biosignatures? They are substances or elements that betray the presence of a form of life, rather like a kind of fingerprint. The search for biosignatures is complex. Our imprint is not necessarily the same as that of another life form. On Earth, for example, the presence of oxygen, methane, and ozone in our atmosphere is a biosignature. But how do we know whether, or another planet, these elements reflect the presence of complex life like on Earth? As you can see, the search for life in the universe is complicated and fraught with pitfalls. Detecting biosignatures is not enough. It's essential to compare them with other observations. For example, imagine a rocky planet, similar in size and mass to Earth. Scientists have detected large quantities of oxygen in its atmosphere. Will they deduce that this planet is inhabited? No, because it's possible that all this atmospheric oxygen is the result of an uncontrollable greenhouse effect, causing all the oceans to evaporate, as on Venus. This overheated planet would be uninhabitable, far from proof of extraterrestrial life. To determine whether or not a planet could support life, researchers will study several factors and compare them. Here's a rough sketch of a potentially habitable planet. First of all, it must be rocky and located in the habitability zone of the star around which it orbits, i.e., neither too close nor too far away. In this way, it will be able to contain water in liquid form, an essential condition for the development of life as we know it, along with minerals and light. It will also have a moderate average temperature, conducive to life, and an atmosphere which protects all forms of life from the star's radiation. A large number of exoplanets with these conditions have been identified, but that doesn't mean they aren't necessarily inhabited. The reverse is also true. A growing number of researchers believe that life could develop in a different environment from the one which is developed on Earth. In other words, a planet might not even need liquid water or moderate temperatures to support abundant microbial life. In the light of these new hypotheses, researchers have broadened their research horizons, making the discovery of another form of life in the universe more likely than ever. Have convincing traces of life ever been found elsewhere in the universe? We begin our journey in the heart of the solar system. You're looking at Mercury, the smallest rocky planet and the one closest to the Sun. Logically, Mercury is also the hottest planet. Its temperatures can reach 430 degrees Celsius. This is the first obstacle to the development of life, and it's not the only one. Mercury has almost no atmosphere, which means its surface is unprotected from the sun's X-rays and UV rays. Because it's so small, this planet is also subject to extreme temperature variations. It can reach negative 180 degrees Celsius or negative 292 degrees Fahrenheit at night, and plus 430 degrees Celsius or plus 806 degrees Fahrenheit during the day. Mercury contains no liquid water. It may have contained some in the past, but this has long since evaporated, not only because of the heat, but also because the gravity of this small planet is far too weak to retain water in liquid form, which would escape into space. Mercury has been considered geologically dead for over 3 billion years. This means it has no internal geological activity, no volcanism, no earthquakes, no plate tectonics. At first glance, it seems obvious that Mercury is uninhabited, and yet, there is water on Mercury. More precisely, Mercury contains icy salt water at its poles. This is what recent scientific measurements have revealed. This icy water is found at the bottom of craters that are never illuminated by the sun and where the temperatures remain constant at around negative 200 degrees Celsius or negative 328 degrees Fahrenheit. Incredible as it may seem, these salt-rich glaciers are likely to harbor life, specifically microbial life. According to the Planetary Science Institute, Mercury's salt glaciers are comparable to certain extreme environments on Earth, which are home to single-cell life. This is the case, for example, of the Atacama Desert in Chile. The researchers used data collected by NASA's Messenger spacecraft to study Mercury's surface. In particular, they found on a region called the Boreal Chaos at the planet's North Pole. This region presents some interesting peculiarities. It looks as if there are ancient craters there that have been erased over time. The measurements revealed extreme environments, but not so different from those on Earth, which are home to a rich microbial life. It would seem that at the bottom of these craters lies a more hospitable environment than on the rest of Mercury. Extraterrestrials may not exist on Mercury, but this small planet close to the Sun may be home to abundant single-cell life. A major discovery, which shows us that in space, nothing can be taken for granted. Scientists must constantly question their assumptions, no matter how certain they may seem. Let's continue our journey with an exploration of another hot planet, where life seems impossible: Venus. Our neighbor Venus is the second closest planet to the Sun. At first glance, it seems obvious that this hellish planet is not home to any form of life whatsoever. It is subject to an enormous greenhouse effect. It's very hot. Temperatures can reach plus 462 degrees Celsius or plus 863 degrees Fahrenheit. Hot enough to melt lead, its atmosphere is 100 times denser than Earth's. It is filled with toxic clouds of sulfuric acid. It is filled with toxic clouds of sulfuric acid, which rain down on the planet. Its atmosphere is 95% carbon dioxide. The pressure on Venus is such that no living thing could survive. It's 90 times greater than on our planet. To give you an idea, walking on Venus would be as difficult as walking underwater on Earth, at a depth of 900 meters. If a living creature were to set foot on Venus, it would be crushed instantly. Unlike Mercury, Venus is also highly active geologically. It is dotted with erupting volcanoes, craters, and lava lakes. All this information leaves no room for doubt. There can be no liquid water on Venus. At least, that's what scientists have long believed. Researchers are now questioning the unusual nature of Venus. This is nothing new. Until the late 1950s, it was thought that Venus's clouds were filled with water vapor, and that the planet was covered with jungles, oceans, and deserts, thriving in a tropical climate. It was thought that Venus could harbor life, and that this life resembled that which prevailed on Earth during the Carboniferous and Permian periods. This idea was quickly dashed by early measurements of our neighboring planet, but it has resurfaced most recently. The question is now being asked whether Venus does indeed offer a mild, tropic climate, not on its surface, but in the thick clouds of its atmosphere. If there's no liquid water on Venus, could water still be present, but in the form of water vapor? This is not a new idea. It's been on the minds of scientists since the late 1960s. In 1967, Planetary Science, Carl Sagan, published an article in the prestigious journal Nature, in which he hypothesized that the clouds of Venus might constitute as ecological niche. Many scientists have taken up his theory, developing scenarios to explain how life could have emerged in the upper atmosphere of the infernal planet. And their models show that this idea is not so far-fetched. At 50 kilometers above the surface of Venus, the temperature is less suffocating. It would be between 30 and 80 degrees Celsius or 86 and 176 degrees Fahrenheit. Pressure also decreases with altitude. At this height, it's equivalent to sea level of Earth. The first evidence in support of this hypothesis came from German astrobiologist Dirk Schultz-Mackig in 2002. Analyzing data from the Pioneer probes, he noticed several anomalies. Not only was the concentration of carbon monoxide measured by the probes astonishingly low, but mysterious dark spots could be seen in Venus's atmosphere, caused by something that seemed to filter out the sun's radiation. Its analysis also revealed the presence of hydrogen sulfide, an element that should have been transformed into sulfur dioxide long ago, unless it continues to be produced by something. All these observations confirm the hypothesis that there are living microorganisms in the clouds of Venus. These would consume sulfur dioxide and carbon monoxide and produce hydrogen sulfide. To do so, they need sunlight. Further analysis over the past 2 decades have continued to confirm that bacterial life could indeed exist in Venusian clouds. In 2020, scientists announced the discovery of phosphine in Venus's atmosphere. A major discovery, since on Earth, phosphine is produced by microbes in oxygen-free environments. The presence of phosphine may be an indication of volcanic activity or a biosignature. Researchers still don't know what it is on Venus that produces phosphine. This discovery caused controversy in 2020, as subsequent studies were unable to confirm it. But more recently, in 2024, Dave Clements and his team made new observations using the Hawaiian-based James Clerk Maxwell Telescope that confirmed the surprising presence of phosphine on Venus. Ammonia has also been discovered on our neighboring planet. On Earth, This element is produced either by industrial processes or by bacteria that convert nitrogen. Even if this doesn't prove anything and further analysis is required, these few discoveries are encouraging and could presage microbial life in the clouds of Venus. Scientists' interest in our sister planet have been rekindled. Around 2030, 3 probes are scheduled to explore Venus, confirming current data on temperature, pressure, and water availability. Living beings on Venus, a far-fetched idea? Not really. Scientists are now convinced that Venus was once home to a multitude of living beings. In fact, several billion years ago, Venus was similar to the primitive Earth. For over 3 billion years, Venus was covered in liquid water, with stable tectonic plates and temperatures close to our terrestrial counterparts, between 20 and 50 degrees Celsius or 68 and 122 degrees Fahrenheit. There were indeed jungles and oceans on Venus, 10 to 300 meters or 30 to 1,000 feet deep. As on Earth, there were also water tables. Venus was therefore habitable and could well have been inhabited. But what happened? "700 million years ago, a major geological event released tons of CO2 into Venus's atmosphere. So far, nothing catastrophic. If such a phenomenon were to occur on Earth, the rocks would absorb most of the CO2 to prevent it from entering the atmosphere in excess. But we don't really know why it happened that way on Venus. Magma solidified on the planet's surface, covering the rocks in a thick, impenetrable layer. The magma smothered the rocks, which could then no longer absorb CO2. This phenomenon is well known. It has already occurred on Earth, leading to the Permian-Triassic extinction, the worst mass extinction our planet has ever seen. On Earth, the consequences were disastrous. Over a period of 60,000 years, which is relatively short on the geological timescale, 96% of all marine species and 3 out of 4 terrestrial species became extinct. Marine ecosystems took between 4 and 8 million years to recover their pre-crisis richness and diversity. The same is true of forests, which were wiped out and took 10 million years to recover their former extent. This event triggered unprecedented global warming, raising water and soil temperatures by several degrees in just 1 million years. 250.2 million years ago, at the height of the Permian-Triassic crisis, sea temperatures reached 40 degrees Celsius, oceans choked and lost more than 3/4 of their oxygen, and rocks were altered by acid rain that carried volcanic sulfur. What if a similar event had occurred on Venus, putting an end to all forms of life and creating the hell we know today? A likely scenario. Venus's atmosphere would have become 90 times denser than Earth's, triggering an unprecedented greenhouse effect. Venus's oceans would have evaporated, wiping out marine ecosystems. The planet's temperature would have risen, and solar radiation would have begun to reach its surface, destroying any life forms that miraculously survived. What if, as on Earth, it was only a matter of time before Venus regained a stable climate and a complete ecosystem? What if all life hadn't been destroyed, but had simply moved into the clouds of Venus's atmosphere, where it would have evolved differently? The probes that will be flying over Venus in the next few years should tell us more. As for us, we're going to continue our journey in search of further evidence of extraterrestrial life in our solar system. We've passed the Earth and are now flying over its neighbor Mars, the red planet. Like our planet, Mars lies in the sun's habitable zone. For decades, it's been thought that if any planet in the solar system is home to life, it must be Mars. Why Mars? Because it's in the solar system's habitable zone, but not only that. Also because, at first glance, it looks a lot like Earth. Like Earth, Mars is a rocky planet with a history of tectonic and volcanic activity. Like Earth, it has an atmosphere. Although its composition is different, it is like our terrestrial atmosphere, animated by currents that generate winds on the planet's surface, responsible for the erosion of rocks. Like the Earth, Mars has polar caps, which evolve according to seasonal cycles. In fact, there are seasons on Mars, which could be explained by the red planet's axis of rotation, similar to that of Earth. Martian seasons are longer than on Earth, as 1 day on Mars is equivalent to 1 day and 39 minutes on Earth. 1 year is therefore equivalent to 687 Earth days. Because of these similarities, people have long wondered whether Mars is inhabited by extraterrestrials, the so-called Martians. To find out, scientists have been searching for liquid water on the red planet since the 1970s. To date, there's been no evidence of life on Mars, but scientists are not giving up hope. In fact, we've come to realize that Mars doesn't look all that much like Earth. Its atmosphere is very thin, which means it lets through UV rays harmful to life, and is composed mainly of carbon dioxide. Mars has no magnetosphere, the layer that protects us from UV rays. Its atmospheric pressure is very low. It is colder than our planet, with temperatures ranging from negative 120 degrees Celsius to 25 degrees Celsius, or negative 184 degrees Fahrenheit to 77 degrees Fahrenheit. Martian soil is rich in oxygen peroxide. The first flybys of Mars by the Mariner 4 probe in 1965 revealed an arid, crater-covered planet, a sign that all geological activity has ceased millions of years ago. No traces of oceans, lakes, or rivers. If there is life on Mars, it can only be unicellular. So, is life on Mars possible or not? Like Venus, it's likely that Mars has hosted some form of life in its past. But that was a long time ago, 4.5 billion years ago, when water flowed freely on Mars and the climate was much more pleasant and conducive to life. Life may well have appeared at the same time as life on Earth, i.e. around 3.8 billion years ago. If this is the case, scientists believe that it was a single-cell life that didn't have time to develop before the Martian water disappeared. How can this theory be verified? By observing the soil on Mars. If unicellular life did indeed develop on Mars, we should find traces of living organisms in the sedimentary layers of Mars, i.e. where the ocean floor was more than 3 billion years ago. To find out, NASA launched the Viking program in the 1970s. The aim of this space program was to carry out experiments on Mars to detect microorganisms in the Martian soil. 50 years on, we have no conclusive evidence of single-cell life, past or present, in Martian soil. But we have found some clues to suggest that there was once water on Mars, and that single-cell life may have developed on this now arid desert planet. First of all, researchers have collected evidence of ancient Martian lakes and oceans, such as these traces found by NASA on February 8, 2023. These traces bear a striking resemblance to those left by liquid water on the arid, rocky surfaces of the red planet. For the moment, the Curiosity rover has been unable to extract samples from this region, where the soil is too hard. Biosignatures such as formaldehyde and silica have also been detected in Mars' atmosphere. These elements are evidence either of past microorganic life on Mars or of volcanic activity. Future missions will certainly enable us to find out a little more. Research on Mars has also revealed a strange phenomenon that could be evidence of subterranean microorganic life: dark dune spots. These dark dune spots on the dunes of Mars were discovered by the Mars Global Surveyor probe in the late 90s. They appeared to be linked to Martian geysers. They appeared in the South Polar region in early spring during the thaw and disappeared before the onset of winter. According to a team of Hungarian researchers, these astonishing dark spots could be evidence of the presence of colonies of photosynthetic Martian microorganisms living beneath the ice layer. When sunlight returns to the poles during the spring thaw, it penetrates the ice and forms shallow pockets of liquid water, enabling photosynthesis. This phenomenon is not unthinkable. It exists on Earth, notably in certain Alaskan glaciers. When wind-blown dust particles settle on the ice, they absorb sunlight and trigger melting, forming chirocronite holes. At certain depths, the sun's heat is no longer strong enough to keep digging. A pocket of meltwater forms, where life can be born and thrive. On Mars, life of this type of environment would be protected from the sun's harmful rays. Because Mars has no ozone layer like Earth, it receives around 30% more harmful UV rays than we do. For life to be likely in these pockets of meltwater, the water would have to be just deep enough to receive sufficient light while being protected from UV rays. This hypothesis is highly probable and has many supporters, but it has yet to be confirmed. According to a 2023 study, it is very likely that life does exist on Mars, but that our instruments are not yet powerful enough to detect it. The instruments used to analyze the Martian soil are barely capable of finding biosignatures in extreme terrestrial environments, such as the Atacama Desert in Chile, where microbial life is known to exist. Not to mention that, for the moment, the rovers sent by NASA to Mars have collected numerous samples that have yet to be analyzed. For that, we'll have to wait until they return to Earth in the next decade, giving rise to its distinctive relief. But it's also true that Ganymede has some features that seem incompatible with life, notably its extreme temperatures, -163 degrees Celsius or -260 degrees Fahrenheit on average at its surface. However, Ganymede is heated from within by the tidal forces exerted by Jupiter and the other Galilean moons. At its center, it's much warmer, over 1,200 degrees Celsius or more than 2,200 degrees Fahrenheit. It's possible then that Ganymede's inner ocean is warm enough to support single-cell life, and perhaps even a more complex form of life. We're now heading for the second gas giant in our solar system, Saturn. Like Jupiter, Saturn is a gas giant with small amounts of water vapor in its atmosphere. On its surface, there's no trace of liquid water. But like Jupiter, the giant planet is surrounded by natural satellites, 146 of which have been discovered. Among these 146 moons, 2 could potentially provide an environment conducive to life: Titan and Enceladus. Titan is Saturn's largest moon, and the second largest in the solar system, after Ganymede. It is the only known satellite to have a dense, opaque atmosphere. Because of its opacity, this atmosphere is difficult to study precisely. But researchers estimate that it is 98.4% diazote and 1.6% methane and ethane. The layers of opaque fog in Titan's atmosphere act as a shield against the sun's harmful rays, a first proof in favor of life. Like the other moons we have observed since the start of this voyage, Titan is extremely cold. Its atmosphere can reach -180 degrees Celsius or -292 degrees Fahrenheit. The pressure of Titan's surface is 1.5 times that of the Earth. As we fly over Titan, you may notice its characteristic dune landscape. This is due to the planet's climate, which is subject to seasons, winds, and methane rain. In the early 2000s, the Huygens probe flew over Titan and detected hundreds of lakes in the moon's north and south poles. A major discovery, Titan has become the only known environment other than Earth to feature liquid expanses on its surface. You're probably wondering how, with a temperature of -180 degrees Celsius or -290 degrees Fahrenheit, Titan can have liquid lakes. In fact, these lakes are not lakes of water, but lakes of liquid methane and ethane at very low temperatures. It would seem that on Titan, methane behaves like water on Earth. Methane not only fills lakes, it can also carve out valleys and form clouds that rain down on the moon. Scientists then put forward a crazy hypothesis. What if methane could be the source of a complex form of life on Titan, like water on Earth? What if methane could enable molecules to mix and interact, like water on Earth? A hypothesis that gives hope to scientists. For if methane can be the basis of complex life on Titan, who knows what other forms of life, different from the one we know, could be found on other planets? To find out, NASA is already planning a mission to explore Titan around 2034, the Dragonfly mission. Saturn's sixth largest moon, Enceladus, is also promising. As you can see, it looks nothing like the other Saturnian moons, with its shimmering white surface, crevices, cracks, and protrusions. These four parallel blue faults that you can see running towards the South Pole are called the Tiger Stripes, 120 kilometers or 75 miles long and several hundred meters deep. These faults radiate heat. In these faults, the temperature is 75 degrees Celsius or 167 degrees Fahrenheit, higher than on the rest of the small moon. From time to time, the friction generated by Saturn's gravitational forces cause immense geysers to erupt from these faults, projecting water into a space at an altitude of 200 kilometers or 125 miles. This liquid water freezes on contact with the cold cosmic air. As on the Galilean moons we have observed, there's an underground ocean beneath Enceladus's frozen surface. This water is well hidden. On Enceladus, it has been snowing for at least 100 million years. The small moon is covered by a thick layer of snow, some 100 meters thick. Scientists have analyzed the water coming out of these geysers and found salt, silica, carbon compounds, and, surprise, heavy organic compounds made up of hundreds of atoms arranged in rings and chains. In other words, complex organic molecules. And that's not all. In June 2023, phosphorus, an element essential to life, was detected on Enceladus. Phosphorus joins the long list of biosignatures discovered on Enceladus: carbon, hydrogen, nitrogen, sulfur, oxygen. While the presence of complex life on Enceladus has yet to be confirmed, we're getting close. Saturn's sixth moon has all the elements required. It is definitely habitable. But is it inhabited? Only time will tell. We've now reached the very edge of the solar system. Uranus and Neptune are two icy planets, made up of water in three forms: icy, liquid, and superionic. Denser than terrestrial water, superionic water is electrically charged, as it is made up of several molecules disassociated into positive and negative ions. Uranus and Neptune may therefore contain liquid water, but are they habitable? Scientists doubt it. Conditions on these planets are hardly conducive to life. They are gaseous planets, extremely cold and battered by ultra-violent winds. Uranus has an average temperature of negative 195 degrees Celsius or negative 319 degrees Fahrenheit, and produces no heat, so it can't harbor an internal ocean. As far as Neptune, the densest planet in the solar system, its temperatures can rise up to negative 208 degrees Celsius or negative 306 degrees Fahrenheit, and its winds up to 2,100 kilometers per hour or 1,300 miles per hour. Nevertheless, researchers are taking a close interest in one of Neptune's 16 moons, Triton. Like the moons we previously visited, it could conceal an internal ocean, maintained in a liquid state by heat production from the core. This liquid ocean could lie between 20 and 140 kilometers, or 12 and 86 miles deep beneath its surface. The problem is that Neptune is a long way away, and the planet has not been overflown much. NASA will try to find out more about this mysterious blue planet with its Trident mission, which will be launched in 2026 and fly past Triton and Neptune in 2038. We will now leave the solar system to continue our quest for life in the universe. The universe is vast. According to NASA, nearly 300 million planets could harbor life in our galaxy alone. This figure does not take into account exoplanets orbiting red dwarf stars. Red dwarfs are smaller, less hot, and less bright than the Sun. They are very numerous in the galaxy and are at the heart of many planetary systems. But these stars are also known for their frequent outbursts of anger. Barnard's star, for example, is shaken by violent storms a quarter of the time. These storms are very likely to make the surrounding planets inhospitable unless they have a particularly thick and robust atmosphere. The planetary system closest to us, and widely studied by scientists, is organized around a red dwarf. This hasn't stopped researchers from wondering whether life could be found in this planetary system. The system in question is Proxima Centauri. Proxima Centauri is the closest star to the Sun. It lies 4.2 light-years from us. It's part of a triple star system around which several planets orbit. Let's move a little closer so you can see the planet that interests researchers. Proxima Centauri b. This planet, located in the habitable zone of Proxima Centauri, is the closest known planet today. This rocky planet is considered a super-Earth, as it is 1.3 Earth masses in size. It is even thought to contain liquid water and an atmosphere, protecting it from the frequent eruptions of the red dwarf Proxima Centauri. In 2019, the Giant Parkes Observatory radio telescope in New South Wales, Australia, detected a strange wave emission as part of the BLIPSS, or Breakthrough Listen project, dedicated to the observation and analysis of signals of life in the universe. This signal, named BLC1, is strange to say the least. It was emitted on a frequency not used by terrestrial devices such as satellites, and it's never been reproduced since. This signal has fueled the wildest hypotheses. Was it emitted by extraterrestrials? Was it communication signal intended for observers in space, like us? Unfortunately, it was discovered in 2021 that the signal originated from Earth, another false lead. On May 1, 2019, Proxima Centauri was rocked by the strongest solar flare ever observed on a red dwarf. This solar flare lasted just 7 seconds, but it was enough to increase the intensity of the star by a factor of 14,000. It's as if the Sun suddenly increased its UV dose by a factor of 14,000. Could life survive such an eruption? If there is life on Proxima Centauri, is it equipped to survive such an eruption? For the moment, we don't know much more. Researchers are facing major difficulties, as conventional methods of detecting signals of life are not adapted to Proxima b. It has no planetary transit. Which prevents us from analyzing its atmosphere. It was discovered by Doppler spectroscopy and not, like many exoplanets, by the transit method. In fact, it was the gravitational force exerted by Proxima b that enabled us to detect it. So we know it exists, but we have no idea if it's habitable. A new study published in January 2024 has proposed an alternative method for searching Proxima b for biosignatures. The idea is to use the reflection of starlight by the planet's atmosphere. Instead of analyzing the light passing through its atmosphere, as with the transit method, we analyze the light directly reflected by the planet. This method has been used for Mars, for example, which does not transit in front of the Sun. But in case of Proxima b, this method represents a real challenge, since the light reflected by this planet is extremely weak compared with the brightness of the red dwarf. It's like trying to capture the light of a firefly next to a powerful spotlight. To make the task easier, researchers use masks to hide the star's brightness and better observe that of the system's planets. The European Giant Telescope, currently under construction in northern Chile, will offer unrivaled capabilities and may well answer many of the questions we have about Proxima Centauri b. We are now 11 light-years from our planet. You're looking at the exoplanet Ross 128b, one of the closest planets in our solar system. This exoplanet was discovered in 2017. Like Proxima b, it orbits a red dwarf star, Ross 128. But this star is rather quiet for a red dwarf, which gives scientists hope. If Ross 128b has an atmosphere, there's a good chance that it's been too badly damaged by its star's eruptions, which are infrequent and, above all, less violent than those of Proxima Centauri. Little is known about Ross 128b. Researchers have estimated that it must be a rocky planet with a mass 35% greater than Earth's and a radius 10% greater. Its equilibrium temperature would be between -60 and +20 degrees Celsius, or -76 and +78 degrees Fahrenheit. Its rotation would be synchronous, meaning it would always face its star in the same way. It would orbit 20 times closer to its star than the Earth does to the Sun, but would release 38% less luminosity, since red dwarfs shine more dimly than yellow dwarfs like our Sun. This is all we know about Ross 128b. We don't know, for example, whether it lies within its star's habitability zone, as this will also depend on its composition and the characteristics of its atmosphere. But we do know enough to estimate the Earth-like index of Ross 128b at 0.86. Ross 28b is the third exoplanet with the highest similarity index, after TRAPPIST-1d, 40.7 light-years away, and Kepler 438b, 475 light-years away. Hence its interest in the eyes of scientists. Like Proxima Centauri b, Ross 28b does not transit in front of its star, making it difficult to study accurately. We'll have to wait for the launch of the ESO's ELT to find out more. In any case, one thing is for certain. If Ross 128b were indeed inhabited by an advanced extraterrestrial civilization, they would most likely be aware of our existence. From Ross 128b, we can observe the Earth in transit in front of the Sun, and thus deduce the characteristics of its atmosphere and its chances of harboring life. It's enough to make you dizzy. Let's continue our journey towards another potentially habitable exoplanet close to our solar system, Wolf 1061c. This planet is located 14 light-years from us. It lies in a solar system organized around a red dwarf named Wolf 1061. This planetary system contains at least 3 planets, all of which are likely to be telluric. Wolf 1061c is considered a super-Earth, as its radius is 1.5 times that of Earth, and its mass is at least 4.3 times that of our planet. To date, no transit of Wolf 1061c has been observed from Earth, but its orbital period is quite short. It orbits a star in just 17.9 days. According to a team of researchers of the University of New South Wales in Australia, there's a 6% chance that Wolf 1061c will pass in front of its star in the near future. Observations using the radial velocity method have nevertheless enabled us to gather some information about this super-Earth. Wolf 1061c receives less than 1% of the Sun's luminosity, and its equilibrium temperature is -50 degrees Celsius or -58 degrees Fahrenheit, slightly warmer than Mars. Close to its star, Wolf 1061c is certainly in synchronous rotation with it. Its climate would probably be chaotic, with short, fast-moving sessions, due to its small orbital period. So, what makes Wolf 1061c habitable? Not much, really. The red dwarf around which it orbits is rather quiet, and this planet appears to be a super-Earth. So we'll have to wait for more information about Wolf 1061c to find out whether it's really habitable. In May 2024, the discovery of a new planet with Earth-like characteristics, like Wolf 1061c, was announced by researchers at the University of Warwick in England. This new planet is Gliese 12b. Gliese 12b is located 40 light-years from our solar system in the constellation of Pisces. Like all the exoplanets we've visited so far, it orbits a red dwarf star. Its star is 27% smaller than our Sun and 60% cooler. According to the BBC, which relayed the discovery of this exoplanet, it is one of the few rocky planets discovered where human life could theoretically be possible. Not only does it lie within its star's habitability zone, it also boasts rather mild temperatures. Its surface temperature is estimated at 42 degrees Celsius or 170 degrees Fahrenheit, assuming the planet has no atmosphere. In fact, Gliese 12b is the closest known planet to Earth in terms of size and temperature. Although the exact composition of the planet's atmosphere is not yet known, scientists are unanimous. It is possible that it contains liquid water. Unfortunately, we won't be able to travel to this planet to find out more. With our current space rockets, we'd have to travel for 225,000 years before reaching Gliese 12b. But once again, the ELT's activation will certainly enable us to gather more information on this promising exoplanet to refine our models. Not far from Gliese 12b, 42 light-years away from our solar system, lies another Earth-like exoplanet, HD 40307g. HD 40307g was discovered much earlier back in 2012. It was one of the first exoplanets to be discovered. It is a part of a planetary system of at least 6 planets, orbiting the Earth HD 40307, an age red dwarf that is rather stable for this type of star. With a mass 7 times that of Earth, HD 40307g is also a super-Earth that could harbor liquid water. Unlike the exoplanets we've explored so far, HD 40307g does not rotate synchronously around its star. So it does have a cold half and a hot half, with the possibility of life confined to the zone of separation, the terminator. But like all other exoplanets we've visited since leaving the solar system, HD 40307g is too far away for us to have any real evidence of its habitability. Let's move on to another interesting exoplanet, located a little further away, 100 light-years from our solar system. This is TOI 700d. The discovery of this exoplanet was announced by NASA in 2020. It is first potentially habitable exoplanet to be discovered by the TESS telescope, which was designed to find Earth-sized planets orbiting nearby stars. It is the first potentially habitable exoplanet to be discovered by the TESS telescope, which was designed to find Earth-sized planets orbiting nearby stars. TOI 700d orbits a small star, 40% the size and mass of the Sun, TOI 700. There are 2 other planets in this solar system, TOI 700b and c. Only TOI 700d is in its star's habitable zone. So logically, it's the one that interests scientists most. What's more, it's almost the same size as Earth, only 20% larger. TOI 700D circles its star in 37 days and receives 86% of the energy supplied by the Sun to the Earth. And that's about all we know about this planet. For the moment, we still don't know the composition of its atmosphere or its surface temperature. But these data are essential if we are to find out more about this planet's chances of harboring a complex form of life. We are now more than 120 light-years from Earth. The further away we are, the more difficult it is to know the precise characteristics of the objects we encounter. But we shouldn't underestimate the power of our latest instruments. The James Webb Telescope, launched in December 2021, has proved highly effective in the search for life in the universe. Above all, it has enabled us to refine the data we already had on certain planets, such as K2-18b, discovered in 2015. Like Wolf 1061c and HD 40307g, K2-18b is a super-Earth. It is 8.6 times more massive than Earth, and located in the habitable zone of its star, which it circles in 33 days. Its star is a red dwarf, making it highly unstable. Scientists therefore concluded that K2-18b could not be inhabited. But as we saw at the start of our journey, nothing can be taken for granted in the study of the cosmos. James Webb's observations have shaken up our beliefs about this tiny planet 120 light-years away. According to the telescope's observations, there is an ocean on K2-18b. In fact, the telescope found carbon-containing molecules, such as methane and carbon dioxide, on this planet, but very little ammonia. And that's not all. James Webb also detected potential signs of dimethyl sulfide, or DMS, on K2-18b, a gas that on Earth is only produced by marine phytoplankton. We know of no other way of producing this gas. Even if there were volcanic activity on K2-18b, this could not explain the presence of dimethyl sulfide on this planet. The research turned the problem on its head and concluded that the most likely hypothesis is that K2-18b has an ocean of phytoplankton-rich water beneath a hydrogen-rich atmosphere. But just because it's the most likely hypothesis doesn't mean it's the best explanation of the mystery. There's no planet similar to K2-18b in our solar system. We therefore don't know the exact nature of its atmosphere. To find out, the James Webb Telescope will make further observations on this promising exoplanet. These new observations will tell us whether dimethyl sulfide is indeed present in significant quantities in its atmosphere. If they confirm this, K2-18b will certainly be the most likely planet currently known to harbor life. Let's move on to another exoplanet that's fueling the wildest hopes of astronomers in search of extraterrestrial life: Kepler 452b. Located 1,402 light-years away, Kepler 452b, like K2-18b, was discovered almost 10 years ago. Like most of the exoplanets we've visited since leaving the solar system, it ticks many boxes in the list of what makes a planet potentially habitable. It's a super-Earth. Its radius is about 1.5 times that of Earth, and its volume about 4 times greater. It's located in the habitable zone of its star, just 5% further from it than the Sun is from the Earth. It takes 385 days to orbit its star. It is probably telluric. With a thick atmosphere and large quantities of liquid water, it has a mass 5 times that of Earth and is certainly volcanically active. Its star is similar to the Sun, being 4% more massive and 10% brighter. The only problem is that Kepler 452b is a long way from us. It lies more than 1,400 light-years from our solar system, in the Cygnus constellation, an immense distance, whether you consider that to reach Pluto in 2006. The New Horizons probe traveled for 9.5 years, while the distance separating us from the dwarf planet is 2.8 million times less than that separating us from Kepler 452b. Because of its distance, we lack too much data to be certain that this exoplanet could harbor life. For example, we don't know the composition of its atmosphere or soil. However, a planet located in a habitable zone may very well not be habitable if its chemistry and geology do not allow for the emergence and evolution of life. This is the case with Venus, for example. Kepler 452b remains very interesting, not only because it is potentially habitable, but also because it could give us a glimpse of what our planets will become in the future. If Kepler 452b is a rocky planet, its position relative to its star shows us that it just entered a period of strong heating. As its star ages, it will release more and more energy. What will happen to Kepler 452b? If it has oceans, they will eventually evaporate, as was probably the case on Venus. The rest we won't be able to observe, but perhaps future generations will. The observation of Kepler 452b will be exciting, as it will enable us to learn more about habitable planets, but also about the future of our own planet. The discovery of potentially habitable exoplanets is not the only clue we can find to the presence of life in the universe. As we saw at the start of our journey, astrophysicists don't just look for biosignatures. They can also look for unusual signs or patterns of light. In fact, anything that poses a real enigma for scientists, any phenomenon that can't yet be explained by our models, can be a clue. Such is the case with the mysterious object FRB 121102, a fast radio burst detected 3 billion light-years away. What is a fast radio burst? It's a very brief and intense radio emission that can be detected billions of light-years from its source. FRB 121102 was detected on November 2nd, 2012. This signal is strange because it's repetitive, emitting repeatedly from the same source. Of course, it's not the only one. Other repetitive fast radio bursts have been detected before, but FRB 121102 is also cyclical. In 2012, FRB 121102 emitted a sequence of repetitive bursts. Then, for 3 years, the source of the signal remained silent. In 2015, the Arecibo radio telescope in Puerto Rico again detected 10 radio bursts from this source over the space of a year. Since then, FRB 121102 has emitted over 200 radio bursts across the universe. In fact, it appears that FRB 121102 emits signals cyclically every 157 days. Researchers were intrigued to find out the source of this strange signal. They discovered that the signal originates from a small, star-poor galaxy around 3 billion light-years away in the constellation of Kocher. It could even be that the signal comes from 2 different sources, one continuous, the other emitting flashes. Are those sources linked? Do they form a single entity or 2 distinct ones? A mystery that is yet to be solved and which thickened in 2016. Researchers have observed a twist in the bursts known as Faraday rotation. This signal occurs when radio waves are twisted as they pass through magnetic fields. In other words, FRB 121102 is very likely to be in the vicinity of an extremely strong magnetic field. To date, this signal is the one with the strongest magnetic fingerprint. Its imprint is 500 times more powerful than other curved bursts, and must therefore be influenced by an unusual event, whose origin we still don't understand. The hypotheses are numerous: a supermassive black hole, a nebula formed by a recent supernova, a pulsar located at the center of the galaxy hosting FRB 121102, or perhaps an advanced extraterrestrial civilization trying to communicate with us. We've come to the end of our journey through the universe, in search of even the smallest clues to the possibility of life elsewhere than on our planet. Not all the planets we visited are potentially habitable. As we've seen, NASA estimates that nearly 300 million planets could harbor life in the Milky Way alone. Sound impossible? And yet, when you think about it, it's the idea that there are no life forms other than our own in the vastness of the universe that seems improbable. We live in an infinite universe. The number of stars, the number of planets, and the number of objects we don't know about all tend towards infinity. So why should we be the only form of life in this infinite universe? Why should the Earth be the only exception, when there are billions of galaxies in the universe? Logic dictates that we're not alone in the universe, and the development of even more powerful space technologies will enable us to go further in our search for clues to extraterrestrial life in the universe. For researchers, finding another form of life is no longer a utopian dream. It's now just a matter of time. The SETI program, Search for Extraterrestrial Intelligence Institute, has more than ever the means to detect possible extraterrestrial communications. Tomorrow, it will be able to pick up signals from other advanced civilizations. And why not decipher them? Our capacity for observation and analysis will also increase tenfold, supported by even more powerful instruments. We'll be able to understand and model every planet we discover, and deduce with a small margin of error whether it's capable of harboring life. The James Webb Space Telescope, ESO's extremely large telescope, NASA's Habitable Worlds Observatory. In a few years or decades, our technology will be ready to finally unravel this mystery once and for all.
In the 1980s, the theory of potential brown dwarfs proved sufficiently relevant for astronomers to systematically include them in their long list of objects to be detected. However, these dark objects emit only weak radiation, which is mainly detectable in the infrared range. Unfortunately, for researchers in search of a major discovery, the detection equipment of the period was not sensitive enough to bring these mysterious objects to light. It wasn't until January 1994 and the arrival of more powerful equipment that the first brown dwarfs were finally observed, confirming this theory. 3 astronomers from the Canary Islands Institute of Astrophysics, using their telescope at Teide on the island of Tenerife, succeeded in capturing one of these extremely discrete stars for the very first time. This is Teide 1, the first brown dwarf to emerge from the shadows, with a mass estimated at between 40 and 60 times that of Jupiter. Located some 430 light-years from Earth in the constellation Taurus, it was hiding in the open Pleiades cluster. Its cold nature was confirmed the following year, in 1995, by the William Herschel Optical Telescope on the island of La Palma. The following month saw the discovery of Gliese 229b, a brown dwarf orbiting the star Gliese 229a. The observation of this object, about 20 to 50 times the mass of Jupiter, was made possible by the use of a coronagraph, an instrument that artificially dims the brightness of its host star. New discoveries of brown dwarfs soon followed. Many of them were detected close to our solar system, where they turned out to be quite old and faint, as well as at the heart of distant clusters of young stars, where they were still relatively bright. As suggested by American astronomer Shiv Kumar, brown dwarfs have lower masses than the least massive stars, but higher numbers than planets. In short, a brown dwarf is either a small failed star or a gas giant superplanet. Brown dwarfs have masses between 13 and 80 times that of Jupiter. While they are not massive enough to sustain the hydrogen nuclear fusion reaction, they are capable of burning deuterium or heavy hydrogen. This distinguishes brown dwarfs from both planets, which don't radiate their own heat, and stars. Deuterium combustion can last for hundreds of millions of years, before diminishing due to lack of fuel. Even so, this phenomenon doesn't allow brown dwarfs to boast high temperatures. Most of them don't exceed 2,500 degrees Celsius, or 4,532 degrees Fahrenheit, well below the temperature of the vast majority of stars worthy of the name. This explains why they emit very little light in the visible range. Instruments capable of measuring infrared light, a type of luminosity imperceptible to the human eye, are therefore essential for detecting and observing these cosmic objects. What's more, infrared waves are blocked by the Earth's atmosphere, making it difficult for scientists to detect them. Fortunately, new measuring devices are now designed to gather a wealth of data from space. These include space telescopes such as the James Webb Space Telescope, equipped with a Canadian NIRISS device for studying brown dwarfs in infrared light. But let's take a closer look at these atypical stars. Let's start with an obvious fact. Brown dwarfs are not brown, but rather have a dark orange-red or magenta hue. Being less luminous than the red dwarfs already listed in the spectra table, their name derives from their dark color. Brown dwarfs are classified according to their spectral type. Unlike main sequence stars, whose energy is derived from nuclear reactions, the energy of brown dwarfs derives from their gravitational energy, converted into internal energy by contraction. The hottest of these, with temperatures close to 2,500 degrees Celsius or 4,532 degrees Fahrenheit, are M6.5 dwarfs, as are very low mass stars, namely red dwarfs. Next in line are the L dwarfs. Cooler than red dwarfs, their effective temperature ranges from 1,026 to 1,726 degrees Celsius, or 3,138 degrees Fahrenheit at most. They are also distinguished by the presence of dust grains composed of metal oxides in their atmosphere, suggesting episodes of molten iron rain. The next category concerns T-dwarfs. Even colder, they have temperatures below 926 degrees Celsius or 1700 degrees Fahrenheit, and therefore emit little or no visible light. In the spectrum of these stars, we can detect lines of methane or carbon monoxide, whose synthesis is made possible by these low temperatures. Finally, brown dwarfs with surface temperatures of around 230 degrees Celsius or 446 degrees Fahrenheit are Y-dwarfs, for which the spectroscopic signature detects ammonia. In the absence of other potential sources of energy in their surroundings, brown dwarfs move from one spectral type to another as they cool. The hottest brown dwarfs, which still benefit from residual heat from their formation, are consequently the youngest and resemble the smallest stars on the main sequence. It's only after billions of years that they join the Y-dwarf category, the coldest of all. The mass of brown dwarfs falls within a fairly wide range. As we've already seen, it can be anywhere from 13 to 80 times that of Jupiter, and must not exceed this boundary equivalent to 0.07 solar masses. Otherwise, hydrogen fusion reactions could be triggered over the long term. Despite this wide range of masses, the diameters of the brown dwarfs vary little. Most of them are slightly larger than the planet Jupiter, by around 10 to 15%. Like planets, brown dwarfs are actually protected from gravitational collapse by Coulombic pressure, the electrostatic repulsive force between protons in an atomic nucleus. Finally, what are brown dwarfs? Are they megaplanets or stars too faint to shine? While it was extremely difficult to distinguish between them when they were first discovered, certain criteria are now measurable. It's fair to say that brown dwarfs are stars in a league of their own and deserve the full attention of the scientific community. But are they anomalies, or are they the missing link that marks the boundary between the heaviest gas giant planets and the lightest stars? Stars are often accompanied by substellar objects such as planets or brown dwarfs. In order to distinguish between these two categories, a number of key factors are studied, enabling us to avoid confusing them. Having defined the mass, shape, composition, and thermal structure of the atmosphere, as well as the orbital trajectory, astrophysicists are now able to classify each observed object. Now let's see what distinguishes a star from a planet. These two objects may appear bright in our night sky, but they are nonetheless different. A star, capable of creating nuclear fusion reactions, shines with its own brilliance. A planet, on the other hand, produces no light at all. It merely reflects the luminosity of a neighboring star. These cosmic objects, with their contrasting compositions, also have different origins. A star is created within a cloud of gas and dust when the latter is dense enough to contract. The star in formation heats up to the point where hydrogen begins to fuse into helium. A star is born as a large dazzling ball of plasma. A planet, on the other hand, forms progressively from gas and dust found in large quantities on the periphery of a young star, notably in its protoplanetary accretion disk. Under the effect of electrostatic forces, these particles agglomerate over time to form a planet of varying mass. when the planet is sufficiently close to the star, it becomes a rocky planet, such as Mercury, Venus, Earth, or Mars. If, on the other hand, it is very far away, it evolves into a gas giant resembling Jupiter. If the boundary between stars and planets seemed obvious, the discovery of brown dwarfs, which are neither planets nor stars, has once again called into question what scientists had taken for granted. Since 1994, numerous brown dwarfs have been discovered, but it was in 2008 that astronomers discovered the missing link between planet and star. A team of French and Canadian researchers who were trying to find brown dwarfs using the MegaCam camera on the Canada-France-Hawaii Observatory Telescope made an extraordinary discovery. Just over 42 light-years away, in the constellation of Cetus, they spotted a brown dwarf with a temperature of just 350 degrees Celsius, or 662 degrees Fahrenheit, the coldest yet detected. Named CFBD S0059, it is colder than ULAS 0034, one of its sister stars detected the previous year, with a temperature of around 400 degrees Celsius, or 752 degrees Fahrenheit. These two stars, which surprisingly display ammonia in their atmospheres, were the originators of the new Y-classified brown dwarf category. Ammonia molecules are non-existent in stars whose temperatures is far too high. As a result, these two brown dwarfs can almost be considered planets. This particularly cold star has also marked a turning point for researchers, who can now refine their atmospheric models, particularly for extrasolar planets with similar temperatures. As a result, the boundary between cooler brown dwarfs and planets is getting thinner. But what about the hottest brown dwarfs? How can we distinguish a brown dwarf from a small, frail star that has lost its brilliance? The answer was published in 2013 by Sergio Dieterich and his counterparts at Georgia State University. They cataloged the photometry of 63 brown dwarfs whose spectral type ranged from M6.5 to L4 in a kind of Hertzsprung Russell diagram that classifies low-mass stars. By comparing these data, they found that the radius of main sequence stars decreases as their temperature increases, but below 1,826 degrees Celsius, or 3,320 degrees Fahrenheit, a sudden gap appears in the distribution of low-mass stars and brown dwarfs. The diagram shows that, like stars, brown dwarfs increase in size as temperatures get lower and lower. In this way, the scientists were able to establish precise values for defining the characteristics of the least massive stars on the main sequence. As a reference star, they chose 2-mass J0513-1403, a very low-mass red dwarf located around 40 light-years from Earth in the Hare constellation. It is in the final stage of its main sequence, as evidenced by its temperature of around 1,826 degrees Celsius, or 3,320 degrees Fahrenheit, a size 8.7% that of the Sun, and a luminosity equivalent to 1/8,000th that of the Sun. This star at the end of its life thus seems to determine the boundary between stars and brown dwarfs. Nevertheless, no population of stars seems to be willing to fill the gap between these two categories. Could this be explained by a different formation of these stars, or even divergent evolutions? In 2013, the mystery still hangs in the air, prompting astrophysicists to delve even deeper into their observations. In spring 2014, the discovery of a very singular brown subdwarf was announced. Detected thanks to joint observations by the Spitzer Space Telescope and the Gemini Observatory, covering both hemispheres, Y0855 is located in the constellation Hydra, just 7.2 light-years from Earth. Although it is the fourth closest star to our Sun and has 5 Jupiter masses, it remains invisible to the naked eye. While its spectral study has revealed that it resembles Jupiter, it is above all the coldest brown dwarf observed at the time of its discovery, with temperatures colder than ice, ranging from -48 to -13 degrees Celsius, or -54 to 55 degrees Fahrenheit. It is also the coldest object known outside our solar system. As cold as our North Pole, this brown dwarf appears to contain water. According to the spectrum obtained after 14 hours of observations spread over 13 nights, Y0855's atmosphere could take the form of water clouds or water ice, giving it an appearance extraordinarily similar to that of Jupiter. This brown dwarf, with its particularly cool hues, is therefore covered in clouds. On the other hand, its atmosphere contains much less phosphine. A lower content of this gas means that its atmosphere is certainly less turbulent than Jupiter's, which is renowned for its devastating winds. The study of this Y2 classified extrasolar spectrum is of paramount importance to scientists. Having long investigated the dynamic and chemical properties of Jupiter's atmosphere, they can now turn their attention to extrasolar worlds. Y0855 finally gives them the opportunity to study such a planetary mass object, almost as cold as our gas giants. Subsequently, many brown dwarfs were found to exhibit slight fluctuations in brightness. So there are variable brown dwarfs. But what is really the case? In research published in 2017, an international team, based on observations obtained by NASA's Spitzer Space Telescope, suggested a novel model to explain these variations. They are linked to the clouds of iron droplets and silicate dust that partially cover certain red dwarfs. These giant clouds seem to change in less than 24 hours, which is very surprising. Organized in bands at certain latitudes, these clouds are subject to the giant atmospheric waves that swirl around the star. Like waves of varying intensity, these waves carry the cloud bands in their wake, causing variations in the object's brightness. This finding is a real breakthrough for the researchers, enabling them to conclude that the atmospheric dynamics of brown dwarfs are similar to those of the gas giants in our solar system. These cold stars, which have long remained anonymous thanks to this observation, are very likely to represent the famous missing link between planets and stars. What's more, scientists believe that the large atmospheric bands and waves observed on the surface of brown dwarfs are probably also common on giant planets in other star systems. This is why the study of brown dwarfs is fundamental to a better understanding of giant exoplanets, especially as they too are composed mainly of hydrogen and helium. Also in 2017, another major discovery was announced. Lead author Zhenghua Zhang from the Canary Islands Institute of Astrophysics reported particularly exceptional results from an observation of a so-called SDSS J01404 plus 1535. This is a brown dwarf about 750 light-years away in the halo of our galaxy, where there is a population of extremely old stars. He said he didn't really expect to see such pure brown dwarfs, and with good reason. Only 0.01% of the star in question corresponds to any chemical element other than hydrogen or helium. The elements initially present in the universe just after its creation, the famous Big Bang, were none other than these same two components, combined with minute quantities of lithium. This brown dwarf is therefore 250 times purer than our Sun. This peculiarity is probably not as rare as one might think, as the same scientist points out that having found one, however, often suggests a much larger, hitherto unknown population. It would be very surprising if there weren't many more similar objects waiting to be spotted. But this sensational discovery is not limited to the composition of this record-breaking brown dwarf. Its mass is just as exceptional for a star in this category. This failed star, probably 10 billion years old, is 90 times more massive than Jupiter. It is therefore the heaviest brown dwarf ever studied, with a mass approaching 9% of solar mass. Among the abundant data collected by the various satellites in action, some of an exceptional nature remain buried in archives for many years before being revealed. When the European Space Agency celebrated the 20th anniversary of the XMM Newton space satellite at the end of 2019, a discovery was made. This heavyweight of X-ray observations, equipped with the most powerful mirrors ever conceived, had captured images of a gigantic X-ray eruption from a tiny star. This exceptional event, suffered by an L-type brown dwarf named J0331-27, on July 5, 2008, lasted just a few minutes, but it was so intense that it caught the attention of scientists. This tiny star, barely 8% of the Sun's mass and barely able to generate its own energy, was nevertheless the source of a flare, 10 times more intense than the most fearsome solar flare on record. For astrophysicists, this is an incomprehensible feat. For an eruption to occur in a star's unstable magnetic field, it must collapse and release stored energy. Consequently, this eruption can only take place if it is supplied with energy, in particular by ionized particles. Ionized particles can only be generated at very high temperatures, which is paradoxically impossible for a brown dwarf of this type, whose surface temperature does not exceed 1,826 degrees Celsius or 3,320 degrees Fahrenheit. As a reminder, our Sun reaches up to 5,726 degrees Celsius or 10,340 degrees Fahrenheit at its surface. Scientists also noted that during the 40 days of observation, no other eruptions occurred on this brown dwarf. This finding is all the more surprising given that such an event is not usually isolated and is part of a series of numerous smaller eruptions. This discovery once again calls into question the conclusions of astrophysicists, who did not believe that a brown dwarf of this type could store so much energy in its magnetic field. According to Andrea De Luca, leader of the team studying the data, it is possible that this type of star takes longer to accumulate sufficient energy before expelling it in a single violent blast. For the time being, the mystery remains unsolved, and future observations of this type should help to shed light on this spectacular anomaly. Another challenge for scientists is to study the winds blowing around brown dwarfs. Measuring the speed of gusts relative to a hard surface like a planet's is easy enough. In the case of brown dwarfs, however, as well as gas giants, which are composed mainly of gas, the task is far more difficult. However, while the upper layers of gas move independently of each other in distinct agglomerations, at depth it's a different story. Here, the pressure is so great that the gas buried at the heart of the star rotates as a single block. The rotation of this inner part is therefore used as a reference for calculating surface winds. In 2020, a team succeeded for the first time in measuring wind speeds on a brown dwarf, named 2-mass J1047 plus 21. Located 34 light-years away, its mass is estimated at between 16 and 68 Jovian masses, with a surface temperature of 600 degrees Celsius or 1,112 degrees Fahrenheit, making it ideal for infrared observation. Thanks to data from NASA's Spitzer Space Telescope, the study of this brown dwarf's luminosity variations has helped determine its surface rotation period, estimated at just over 1.741 hours. To assess the speed of the star's inner lump, scientists turned their attention to its magnetic field. The study of radio waves emitted by this celestial body using radio telescopes has established that the rotation period of the brown dwarf is between 1.751 and 1.765 hours. The difference between the two rotation periods enabled us to determine that the surface winds sweeping eastward over this brown dwarf are blowing at the prodigious speed of 1,116 kilometers per hour. This innovative technique should make it possible to study the atmospheric dynamics of distant worlds, i.e., planets far from our solar system. Some failed stars, too cold to be discovered due to their weak infrared emissions, can now be detected by another method. In 2020, a team of researchers published a study revealing that they had, for the first time ever, succeeded in locating a substellar object by detecting its radio emission. BDR J1750 plus 3809, a cold brown dwarf nicknamed Elagast, was detected by radio astronomers using the LOFAR radio telescope. This device is so powerful that it can pick up magnetic fields comparable to those of a magnet's small electromagnet. So, after the scientists had detected radio images propagating in the form of circular polarization, they continued their infrared observations with a Gemini telescope and NASA's Infrared Telescope facility, confirming that they had indeed succeeded in detecting a brown dwarf. This discovery paved the way for astronomers to detect low-emission objects, such as exoplanets, with features in common with Jupiter. By studying the magnetism of brown dwarfs, which is similar to that of planets in our own solar system, scientists hope to learn more about the magnetism of extrasolar bodies and its impact on exoplanets that might be able to harbor some form of life. Brown dwarfs, only recently discovered, are on the radar of many astronomers. As a result, one revelation follows another in a very short space of time, thanks in no small part to the use of innovative, increasingly powerful technologies. In 2021, it was READ 1b that made the news. This brown dwarf, 17 light-years distant, has an estimated mass of 41 Jupiter masses and appears to be 1.1 billion years old. As you know, these substellar objects are made mostly of hydrogen and helium. However, they do contain a few heavier elements in small quantities, notably lithium. However, during their first few hundred million years of evolution, the internal temperature of brown dwarfs reaches 2 million degrees Celsius, destroying lithium by thermonuclear fusion. As a result, this element is considered a rare material, both in our solar system and in our cosmic neighborhood. To their great surprise, scientists searching for lithium-bearing stars discovered a veritable treasure trove. Concentrating their observations on two binary systems of brown dwarfs, one of them caught their full attention. While the other three are devoid of any trace of this element, READ 1b possesses an unimaginable quantity. According to their estimates, it contains 13,000 times more lithium than our planet Earth. This brown dwarf, which is the faintest and coldest of the four objects studied, confirms that this type of star can be considered the largest deposit of lithium. Battery manufacturers would be delighted to get their hands on such a vein, this rare element having been almost entirely destroyed by our Sun when it was still located in the Earth's core. Recently, in June 2023, a team of astronomers claimed to have identified a brown dwarf that does not meet the usual criteria for this type of object located at the boundary between the worlds of planets and stars. For a start, it has a mass never before equaled for such an object. This brown dwarf holds the record in its class, with a mass of between 75 and 88 Jovian masses. Because of this particularity, the star is at the stellar-substellar limit, just below the lower limit for hydrogen combustion. And yet, while the surface temperature of a brown dwarf is not supposed to reach 2,000 degrees Celsius, or 3,632 degrees Fahrenheit, the one observed here is extremely hot, even hotter than our Sun, which can heat up to 5,500 degrees Celsius or 10,000 degrees Fahrenheit on its surface. WD0032-317b, a brown dwarf some 1,400 light-years away, burns at exactly 7,730 degrees Celsius or 14,000 degrees Fahrenheit. How can a brown dwarf have such a high surface temperature? In theory, this temperature should not be possible. So scientists set out to find why. By observing this brown dwarf, they realized that it orbits an ultra-hot white dwarf at such a short distance that it completes one revolution in less than 2 hours 30 minutes. This proximity, like the Moon's proximity to the Earth, prevents the brown dwarf from rotating on itself, so it continually displays the same face to its hyper-hot neighbor. On the other hand, if its exposed side reaches unpredictable temperatures, its dark side must have degrees between 1,000 and 2,700 degrees Celsius, or between 1,832 degrees Fahrenheit and 4,900 degrees Fahrenheit. This particularity, if confirmed, would make this brown dwarf the substellar object with the largest temperature differential ever observed. However, this exposure leads to a process of thermal dissociation, causing evaporation of the brown dwarf's atmosphere which will one day fade away entirely. Among the most extraordinary discoveries concerning brown dwarfs, the one nicknamed the accident is probably the most interesting of all. Discovered in 2018 by Dan Castleton, an amateur scientist researching the many images of the WISE Space Telescope, this brown dwarf, designated WISE J153429.75, has some strange features which explain why it wasn't spotted earlier. Its infrared spectrum, the characteristic that identifies brown dwarfs, is unlike that of other similar stars. The spectrum of this brown dwarf, which we'll call the accident for convenience, is dark where it should be bright, and vice versa. As a result, this brown dwarf is unlike any of its 3,000 or so comparses already explored in our Milky Way. In an attempt to understand these properties, which contradict known concepts, scientists tried to observe it in additional infrared wavelengths using a ground-based telescope. Unfortunately, the object remained in shadow, confirming that its temperature must be extremely low. After thinking that the object was too distant to reveal itself to this type of instrument, they gauged its distance with measurements taken by the Spitzer and Hubble space telescopes. Not only did they find that the object was only about 50 light-years away, but more importantly, its speed was estimated to be particularly fast. This brown dwarf is moving at an estimated 800,000 kilometers per hour, or 500,000 miles per hour. Once again, this brown dwarf doesn't behave like its counterparts, which travel more slowly around our galaxy. What's more, this unusual object contains low levels of methane compared with other brown dwarfs. In the face of so many discrepancies, scientists suggest that these unusual features may not be so strange after all, suggesting that we are almost certainly dealing with a star that is much older than any other in its class. Initially disconcerted, the scientists consider that the particularities of this star make it possible to estimate its age at between 10 and 13 billion years. This would make it twice as old as any other brown dwarf in the galaxy, whose average age is much lower. This brown dwarf has been spinning longer than others, and over time has encountered numerous massive objects, whose gravity has gradually increased its speed. Its low methane concentration also justifies its advanced age. Since its formation probably dates back to the early days of the Milky Way, when it was still low in carbon, massive supernovae would not yet have distributed large quantities of carbon atoms throughout the cosmos. Indeed, a low carbon content at the time of its formation explains its current low methane content. Be that as it may, this discovery is of the utmost importance. Either it's a rare chance to observe an unusual object, or it's a promising one. For scientists, it could well be the answer to the desert of brown dwarfs seen in the Hertzsprung-Russell diagram that classifies stars. Remember that the missing link between an extremely low-mass red dwarf and the most massive of brown dwarfs? What's certain is that astronomers can now recognize old brown dwarfs. It remains to be seen whether they are actually more common than scientists thought. You may not have noticed, but we alluded earlier to a binary system containing a brown dwarf. Just as stars can evolve in multiple systems, brown dwarfs are sometimes accompanied on their long cosmic journey. In 2020, astronomers revealed that they had made a rare discovery while on the hunt for exoplanets. Their quest, carried out with state-of-the-art robotic telescopes called Speculus, was to detect potential habitable planets in the vicinity of brown dwarfs. Pointing one of their 1-meter diameter telescopes in the direction of an already cataloged brown dwarf, they were intrigued by a strange phenomenon. The object, located 119 light-years away in the constellation Libra, was already faint, but darkened considerably over a period of around 90 minutes. The object, commonly known as 2M1510A, had just been occulted during an eclipse. Observations also confirmed that a second signal was coming from this area, enabling astronomers to envisage a second brown dwarf orbiting 2M1510A. The scientists then realized that they were in the presence of a system much rarer than planetary systems, this one being composed of 2 eclipsing brown dwarfs, one passing in front of the second. The 8-meter telescope in Chile and the large Keck telescope in Hawaii quickly confirmed this suggestion. The 2 elements have roughly the same mass. The first, 2M1510AA, has a mass of 40 Jovian masses, while the second, 2M1510AB, has 39.3 Jovian masses. Assiduous observations have enabled astronomers to assert that the 2 brown dwarfs orbit each other in 21 days. But another discovery followed. These 2 closely spaced objects have an additional companion. Named 2M1510b, it is of the same nature as the binary system already studied. This tertiary brown dwarf, although far removed from the main duo, is indeed part of this system, nestled in a 45-million-year-old cluster of stars known as the Argus Mobile Group. This discovery is of particular interest to scientists. For one thing, the age of the system is similar to that of exoplanets currently under observation. Studying the evolution of these objects compared to the mathematical evolutionary models assumed could be of great use in the study of young planets in progress. What's more, apart from 2M0535, no other double-line binary eclipsing brown dwarfs were known at the time. However, the latter remains difficult to observe due to its young age, being part of the Orion nebular cluster, only 1 million years old. Since then, 6 other triple systems of brown dwarfs have been discovered, but 2M1510 remains the only triple system for which the major characteristics of all 3 components have been determined: mass, radius, and age. What's more, these 3 brown dwarfs have approximately the same mass, while displaying the narrowest separation ratios between their different orbits of all, making this triple system even rarer. Following this discovery, scientists were able to cross-check 30-year-old theoretical models of brown dwarf cooling. They found that these models superimposed admirably on the observations, confirming the astrophysicists' hypotheses. The discovery of this system therefore represents a tremendous opportunity to understand how brown dwarfs evolve and cool as they age, and at the same time, to better characterize the formation process of young exoplanets. In a closer environment, 6.5 light-years from our solar system, a binary system also made news in 2021. Luhmann 16AB, made up of 2 brown dwarfs, is the closest star system to our Sun after Alpha Centauri and Barnard's star. These 2 brown dwarfs are roughly the same size as Jupiter, but around 30 times more massive. Although already known, Their close-up observation with the Hubble Space Telescope proved surprising. Not only did it allow us to follow the cosmic waltz of the two objects circling each other, but it also helped us collect a wealth of precise data for modeling the structure of the clouds in their atmosphere. After observing the system for 100 rotations using NASA's TESS telescope, the international team came to a surprising conclusion. Brown dwarfs, like Jupiter, don't have spots in their atmosphere, but stripes. Luhmann 16b, the more massive of the two, shows in this polarimetric study thin bands of clouds that allow its light to filter through, as well as other, much darker, and consequently thicker bands of clouds. The latter rotate rapidly around the equator, creating two vortexes at the poles. The appearance of this brown dwarf is explained by the presence of powerful winds sweeping across its entire surface. These are by no means localized storms, as the bands run parallel to the equator. Luhmann 16b is thus animated by high-speed winds, which, like terrestrial jet streams, mix the atmosphere and redistribute the heat emanating from the star's interior, giving it a striking resemblance to Jupiter. The study of this brown dwarf is of the utmost importance to scientists. It enables them to better understand the climates and temperature extremes of brown dwarfs, as well as their evolution in general, and more generally, the atmospheres of extrasolar celestial bodies. From there, a question is probably burning on your lips. Could Jupiter be a brown dwarf after all? We've just seen that the nearest failed star to our solar system bears an uncanny resemblance to it. The question therefore seems legitimate, especially as Jupiter is the largest planet in our solar system and the minimum mass required for brown dwarfs is currently only hypothetical and observational. In reality, Jupiter cannot be a brown dwarf. On the one hand, it has insufficient mass to ignite deuterium fusion, which is around 0.001 solar masses, whereas a brown dwarf must have at least 0.012 solar masses to generate nuclear fusion. On the other hand, Jupiter, which has a solid core enriched in heavy elements, formed from the accretion of gas and dust in a protoplanetary disk around our star. However, brown dwarfs composed mainly of hydrogen and helium are born like a star, after the gravitational contraction of an interstellar cloud. What's more, Jupiter has been cooling gradually since its formation, whereas a brown dwarf maintains its high internal temperature due to deuterium fusion over a very long period. So no, although its appearance might suggest otherwise, Jupiter is not a brown dwarf. However, a very recent study published on December 13, 2023, may well have detected the smallest brown dwarf ever imaged directly. Thanks to the NIRCam instrument on the James Webb Space Telescope, a candidate brown dwarf whose mass appears to be only 3 to 4 times that of Jupiter has been spotted 1,000 light-years from Earth in the constellation Perseus at the heart of the IC 348 nebula. This cluster of gas and stellar dust is only 5 million years old, which explains why 3 candidate brown dwarfs have been spotted there, still bright enough to be seen in the infrared. This study has thus revealed this potential floating brown dwarf to be strangely low mass, compared with all those observed to date. But in addition to this unprecedented record, another peculiarity was noted. Low-resolution spectroscopy of these 3 failed stars, which don't exceed 8 Jovian masses, revealed the presence of an unidentified hydrocarbon in their atmosphere. As European Space Agency scientist Catarina Alves de Oliveira points out, this is the first time we have detected this molecule in the atmosphere of an object outside our solar system. Composed of carbon and hydrogen, this molecule has so far only been detected on Saturn and its largest moon, Titan, as well as in interstellar space. For the researchers, this observation is more than surprising, especially as no atmospheric model for brown dwarfs has ever predicted the existence of such a molecule. There is no doubt that the increasingly sophisticated technical means available for observing objects that are younger and less massive than ever before will continue to give scientists the opportunity to make unexpected discoveries. If this object, estimated at between 3 and 4 Jovian masses, is confirmed as a brown dwarf, it will be the least massive ever imaged. It would help advance science, which is trying to answer a fundamental question. What are the smallest stars? Are there even lower mass stars? Stars with the mass of Jupiter? What's more, this discovery poses a new challenge: how to explain the formation of such a small brown dwarf. If the boundary between less massive brown dwarfs and gas giant planets is not yet clearly established, the same is true for the boundary that separates these failed stars from stars. However, the discoveries we are now making at an ever-increasing pace are considerably narrowing these boundaries. Earlier, we touched on a category of brown dwarfs with exceptional qualities, including the most massive ever discovered to date, namely WD0032. In July 2023, a team of astronomers led by Kareem El-Bedri of the California Institute of Technology reported having detected a new object of extreme mass, around 80 times that of Jupiter. This observation was made possible by the Zwicky Transient Facility, which is designed to survey transient astronomical objects. This system provides a wide-field astronomical survey of the sky using a new camera installed on the Samuel Ocean Telescope at the Palomar Observatory in California. It can record a wealth of data, including that relating to transient objects. In other words, those whose light changes rapidly. While scientists were on the lookout for low-mass binary eclipses, they detected a system composed of an M-type dwarf star and a brown dwarf. This system has been named ZTF J2020+5033. It comprises an M-dwarf star, the most common of all stars, small and cold, whose exact spectral type is M6. Its radius is 0.176 solar radii, and its mass is 0.134 solar masses, or 140 Jovian masses. Its effective temperature has been estimated at 2300 degrees Celsius, or 4172 degrees Fahrenheit. This tiny star's companion is a brown dwarf, whose mass is approximately 80.1 times that of Jupiter, the largest planet in our solar system. It is therefore a substellar object, i.e., a substar unable to fuse the hydrogen in its core, as its temperature of around 1400 degrees Celsius, or 2552 degrees Fahrenheit, is insufficient. According to scientists, this system, located approximately 445 light-years from Earth, has another feature that makes it even more incredible. The two objects in this system are closely linked, with the brown dwarf orbiting its star in less than 2 hours. The failed star completes its revolution in just 1.9 hours, or 114 minutes. These two objects present the narrowest orbit ever observed between two uncollapsed stars. For the researchers, this discovery finally confirms that magnetic braking, the process that shortens the orbit of an uncollapsed star around another object, applies equally when the object in question is a brown dwarf. Of the 39 other similar systems listed to date, this one is closer than 34 of them. For the scientists, this singularity, which ultimately turns out to be observed in several cases, prompts them to suggest that brown dwarfs with short-period orbits are not as exceptional as they previously thought. Once again, this is an important discovery, providing a better understanding of the evolution of brown dwarfs and their diversity. According to their projections, the two objects then observed, when they formed several billion years ago, must have been 5 to 10 times larger than they are today. As a result, they were also much further apart. However, this rapprochement is not over yet, and the brown dwarf's mad rush is set to reach a violent conclusion in a few tens of millions of years' time. Although slightly higher, the star's surface gravity will begin to absorb material from its fellow traveler. Inexorably, the brown dwarf is bound to disappear. Will it be swallowed up by its host in a slow but irreversible fusion? Or will a massive explosion occur? In either case, the brown dwarf will disappear forever, while a new star is born. Unless something else happens. In a study published in 2006, scientists report, after studying a binary system using the European Southern Observatory's Very Large Telescope, known as WD-0137-349, that a brown dwarf may well have outlived its mutant star. Located some 330 light-years from Earth, this system is made up of a white dwarf and a brown dwarf, with a tight orbit of just 2 hours. The latter, christened WD-0137-349b, as extraordinary as it may seem, would not have been swallowed up by its hungry companion star in its red giant phase. Prior to this observation, only stars with a mass of around 1/3 that of the Sun were known to persist in such circumstances. And yet, while the main star temporarily expanded its gaseous envelope, as all red giants do, it failed to completely vaporize the brown dwarf. In the process, the red giant slowed its companion's orbital speed, drawing it ever closer to its center in a downward spiral. But the brown dwarf, with a mass in excess of 20 Jovian masses, was massive enough to avoid the worst, even if it didn't qualify as a bright star. Scientists also suggested that the failed star probably accelerated the red giant phase of its host. The engulfed brown dwarf would have accumulated matter, which it would then have expelled back into the cosmos, considerably collapsing the red giant's gaseous envelope. While the phase of isolated red giants is supposed to last around 100 million years, in this case, this one could well have passed through this stage in just a few decades before entering its final stage as a white dwarf. This brown dwarf is therefore the smallest known cosmic object to have survived engulfment by a red giant. Until this unprecedented observation, only red dwarfs had met this challenge. However, the fate of this brown dwarf is far from sealed. Although it has accomplished this feat once, it has only given itself a reprieve and will not be able to thwart its future destruction. its orbit will continue to shorten, and within 1.4 billion years its proximity to the red giant turned white dwarf will set in motion a process, this time unstoppable. The star will begin to drink in the surface gases of the brown dwarf, which will slowly but surely lose much of its mass. Then, when the white dwarf has accumulated enough material, recurrent novas will occur until there's not a crumb of the valiant brown dwarf left. Although these dark stars are being observed more and more, there's still a great deal of mystery surrounding them. While we know that they possess some of the characteristics of gas giant planets like Jupiter, as well as features typical of stars, each of their discoveries proves exciting, bringing its own share of surprises. Indeed, in July 2020, NASA made another announcement, declaring that 2 new brown dwarfs with strange characteristics had just been discovered. Their observations, which had been buried in the extensive WISE satellite data collected since 2009, were unveiled thanks to a research program involving amateur scientists. The project, named Backyard Worlds, Planet 9, and funded by NASA, aimed to detect the hypothetical 9E planet, which could nestle at the margins of our solar system, as well as new brown dwarfs. But as the researcher in charge of this project points out, there is still no substitute for the human eye when it comes to recognizing subtle movements in astronomical images. To scan these countless naked eye images, the scientists therefore turned to amateur astronomers. While no planets were spotted, this collaborative study did reveal the presence of 3 brown dwarfs with more than exceptional features. The first, named WO-830, turns out to be the coldest stellar-type object ever detected. The data studied were so unconvincing that Dan Castleton, one of the amateur participants in this study, didn't believe it was real. However, with the help of observations from NASA's Spitzer Space Telescope and its Hubble counterpart, scientists have confirmed this strange discovery. WO-830 does indeed have an extremely low temperature for this type of object, ranging from 26 to 76 degrees Celsius, or 79 to 169 degrees Fahrenheit. For Daniela Bardelez Gaglioffi, lead author of the study and researcher in the museum's astrophysics department, this brown dwarf is the coldest ever detected. But the same scientist revealed another peculiarity. She points out that the coldest brown dwarf previously known belonged to a class of brown dwarfs in its own right, much redder than any other brown dwarf on record, with no explanation for this singularity. This new brown dwarf could well be the famous missing link that closes this gap. For her, there's no doubt that future observations should help to link these elements, and in so doing, understand all the correlations between these faint and exceptional objects. Among the extraordinary discoveries announced during this study, 2 other brown dwarfs stood out. What makes them special? They bear a striking resemblance to the most planetary objects ever found among the Milky Way's oldest population of stars. These 2 atypical brown dwarfs, named WISE 1810 and WISE 0414, have masses equivalent to around 75 Jovian masses and are probably both around 10 billion years old. The former had already been spotted a few years earlier, but was hiding in the plane of the Milky Way, where stars abound. A study of the star's movements over a period of several years confirm that it is moving fast, and therefore that it is in our solar neighborhood. The WISE images studied have enabled us to classify it as a brown dwarf. The discovery of Y0414, on the other hand, is the work of amateur scientists, who, after examining a large number of images obtained by the WISE mission, detected its almost imperceptible movements. While more than 1,600 brown dwarfs and a few white dwarfs were discovered during this research program, these two brown dwarfs stood out from the rest, not least for their composition, which proved to be particularly unusual. These brown dwarfs, both around 10 billion years old, and each with an estimated mass 75 times that of Jupiter, contain very little iron. One of them contains just 3% more iron than our Sun. Like ancient stars, they have not amalgamated iron from the birth or death of stars in their environment. However, typical similar objects contain up to 30 times more iron or other usual metals. For scientists, this latest discovery is of the utmost importance. It raises the possibility that very ancient exoplanets may have the same property, low metal content. Future searches for exoplanets should therefore focus more intensively on metal-poor objects, or those orbiting ancient stars with this same characteristic. For astrophysicist Mark Kuchner, one of the principal investigators of this program, these two brown dwarfs, with properties surprisingly similar to those of exoplanets, should enable us to learn a great deal more about the physics of exoplanets. An equally sensational phenomenon has been observed on a brown dwarf located 20 light-years from our Sun. Using radio and optical telescopes, an international team of scientists from the University of Oxford and the University of Sheffield have reported a strange fact, suggesting that brown dwarfs behave more like large planets than small stars. Numerous observations of images dating back to 2015 have led physicists to conclude that this failed star exhibits powerful aurora borealis, similar to those seen on our Earth. These are reflected in pulses of radio and light that vary periodically as the object rotates. As the object rotates every 2.84 hours, 3 complete rotations were observed in a single night, confirming the presence of a bright element on its surface. Like the Earth and Jupiter, which have strong north and south magnetic poles, this brown dwarf, and certainly many others, is the scene of magnificent aurora borealis, when plasma is trapped in the magnetic field near one of these poles. Electrons then collide with the brown dwarf's atmosphere, which is essentially made up of hydrogen, producing these beautiful luminous effects. Astronomers were extremely surprised by this discovery. While the chaotic magnetic field at the Sun's surface causes intense sunspots, demonstrating that stars are adorned with dark spots, while planets display magnificent polar auroras, the object studied calls this postulate into question. In this case, we're talking about a brown dwarf, which belongs to the mass category of stars. However, the scientists had the privilege of observing not spots, but splendid polar aurorae, which are usually phenomena associated with certain planets. Scientists had already accepted that brown dwarfs have cloudy atmospheres like planets, but their clouds are made up of minerals. Now they are able to assert that their magnetic fields, like those of certain planets, are responsible for the aurora borealis. So should brown dwarfs be considered as enhanced planets rather than failed stars? Whatever the case, the weak radio emission of this type of luminous phenomenon has since become a new means of detecting and studying exoplanets. Thanks to the NIRCam infrared camera carried by the James Webb Space Telescope, an international team of scientists declared in spring 2023 that they had identified a binary system with novel characteristics. It consists of two Y-type brown dwarfs, the least massive in their class. While one of the two objects, a close YO-type brown dwarf, had already been detected in 2012, an object observed in September 2022 turns out to be a companion of the same category. We'll call this system WO336 for short. It is located in the Eridan constellation, some 32.7 light-years from Earth. The two brown dwarfs are about 0.97 astronomical units apart, or slightly less than the distance from Earth to the Sun. Scientists estimate the mass of the primary brown dwarf to be between 8.5 and 18 Jovian masses, compared with 4 to 12.5 Jovian masses for the second. Their temperatures are respectively 141 degrees Celsius or 256 degrees Fahrenheit and 52 degrees Celsius or 125 degrees Fahrenheit, the latter being similar to Earth's temperature. These two low-mass brown dwarfs orbit each other with an estimated period of around 7 years. For scientists, the discovery of this pair represents a tremendous opportunity. While they had concluded that most of the massive brown dwarfs forming a system were twins with relatively similar masses, a result explained by the star formation process, they couldn't say the same for lower mass objects such as Y-type brown dwarfs, especially since most closely related binary systems do not have such a low mass ratio. Is this an exclusive system, or does it represent the majority of binary systems composed of ultra-cool dwarfs? For the moment, one thing is certain. With this duo, they have demonstrated their ability to directly measure the masses of the least massive substellar objects, and will probably subsequently be able to determine the minimum lower mass that a Y-type brown dwarf can then present. However, the boundary between the planetary and stellar worlds, while diminishing, still remains a mystery, especially as an upper limit to a planet's mass is still unknown. Although they have long remained invisible, brown dwarfs have proved to be fascinating objects in the course of their discovery. Neither star nor planet, too small to trigger hydrogen fusion and shine brightly, and too massive to belong to the planetary type, they make up a family in their own right. Considered aborted stars, brown dwarfs nonetheless bear a striking resemblance to gas giants. Some have clouds of water in their atmosphere, suggesting the presence of water vapor or ice. Others have been shown to irradiate their surroundings with their powerful magnetic field, protecting potential satellites from cosmic radiation. If their surface temperatures, like their surface gravity, make life as we know it unlikely, could it be that life forms adapted to these extreme conditions exist in a close enough environment? Exoplanets orbit some of them. Could they just be worlds, each more sterile than the last? To find out, we'll need to explore them one day. Brown dwarfs, like silent witnesses to the diversity and complexity of the universe, invite us to imagine unsuspected possibilities. while pushing back the limits of our knowledge.